All right, so I think this is recording. Let's take a look at this problem number 12. It's a radical equation, but I noticed that on the left-hand side I have two radicals, and these problems are not really any harder than if it has one radical, but they are longer. Um, so let's isolate one of these radicals. I really don't have a rule of thumb as which one to choose. So I'm going to add the square root of x minus 3 to each side. I'm going to get the square root of x plus 5 by itself. So this is what I get when I do that. So now on the left-hand side, if I square this radical, that radical will go away. However, on the right-hand side, I suggest that you multiply this out in the form of a table. Exponents don't distribute. So what do we have? Well, we have 2 times 2 is 4. 2 times this radical is just 2 radical x minus 3, and so is this term. And when you have a radical and you multiply it by itself, why the radical goes away, we have x minus 3. So now on the left-hand side, I have just x plus 5. And on the right-hand side, well, let's add these like terms along this diagonal. And I have x plus 1, because 4 minus 3 is 1. And along the other diagonal, these are like terms, so I have 4 of these radicals. So now I've gone from an equation that had 2 radicals to an equation that just has 1 radical. So although it still looks complicated, it is less complicated than what we started with. So let's subtract x from both sides, and this term cancel. So, and I'm also going to subtract 1 from each side. 5 minus 1 is 4. And then I have 4 times x minus 3. If I divide each side by 4, I have 1 is equal to the square root of x minus 3. If I continue over here to the right, if I square the left-hand side, I need to square the right-hand side, and that will get rid of this radical. And remember, every time I'm squaring this, I'm doing a non-invertible operation that introduces extraneous solutions into this problem. So when I get to my final answer, I'm going to have to plug it in the original equation to check and see if it's satisfied. 1 squared is 1. When I square this radical, the radical goes away. If I add 3 to each side, then I'm getting a possible solution of 4. So let's check that. On the left-hand side, if I replace x with 4, I've got the square root of 4 plus 5 minus the square root of 4 minus 3. And the big question is does that equal 2? Well, 4 plus 5 is 9, and the principal square root of 9 is 3. 4 minus 3 is 1, and the principal square root of 1 is 1, and 3 minus 1 does equal 2, so this checks. So hey, I hope that helps. Ask any questions if you need to. Let me know if I make silly arithmetic errors, because I can come in and edit these videos and help other people. So I will talk to you later. Bye.